Now in this lecture we find out the radius of a circle. In the drawing we have the right triangle ABC. This is an ABC, it is the right angle, it is equal to 90 degrees. Line segment AS or the right angle ABC equals to 1 unit. Line segment ST equals to 3 units. And this is line segment TC, this is equal to 2 times square root of 3 units in its length. Inside this right angle ABC we have this circle, and our mission is to find out the radius of this circle. So first of all, we will define the center of this circle, this point as O. And we define the radius of this circle, that is the radius that we are looking for in this question. We define the radius of this circle as x. So our mission is to find out the value of x. In the next step, we will join points O and Q together by a straight line. So what is the definition of line segment OQ? Line segment OQ starts from point O, that is the center of the circle, and ends at point Q, that is a point on the circle itself. So this is exactly the definition of a radius. Therefore OQ is the radius of this circle, that is equal to x according to our definition. You can implement rule 1. I will repeat quickly on rule 1. According to rule 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So in the drawing we have a circle, and we have, this is tangent AB, it is tangent to this circle here at point M. And we also have the radius OM that is drawn to point M, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius MO. If AB is perpendicular to MO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to this rule, rule 1. We can actually implement rule 1 in our drawing. Why? Because in our drawing we have the radius OQ of this circle that is drawn to point Q, that is the point of tendency of tangent BC with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius QO. If BC is perpendicular to QO, it means that this angle equals to 90 degrees. And this angle also equals to 90 degrees according to rule 1. Likewise, we join points O and P together by a straight line. P is the point of tendency of tangent AB with this circle. So OP is the radius of this circle, that is equal to x according to the definition. And here we have the radius OP that is drawn to point P, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius PO. If AB is perpendicular to PO, it means that this angle equals to 90 degrees. And this angle also equals to 90 degrees according to rule 1. So inside this quadrilateral PBQO we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this fourth missing angle, in total the sum of those 4 angles must be equal to 360 degrees. Therefore, the missing fourth angle here must be equal to 90 degrees in its size. Again, in order to complete the sum of the angles inside this quadrilateral POBQ to 360 degrees, the missing angle here must be equal to 90 degrees in its size. So inside this quadrilateral POQB we have 4 right angles, and any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So we relate to this quadrilateral POQB is a rectangle. But we also know that the opposite sides of a rectangle are equal to each other. So a rectangle POQB, side PO is equal to the opposite side PQ. But PO equals to X, therefore BQ must be also equal to X because of the fact that they are equal to each other. Likewise, according to the same rule, in the same triangle POQB, in the same rectangle POQB, side OQ must be equal to the opposite side PB, but OQ equals to X, therefore PB must be also equal to X because they are equal to each other. So I actually found out that quadrilateral POQB is not a rectangle but a square. In the next step, we define the length of this line segment AP as A. And we will define the length of this line segment QC as B. So, in the next step, we will implement Rule 10 in our drawing. I repeat quickly on Rule 10. According to Rule 10 is true in any circle. So in any circle, if we have the common standpoint point P, we also have from the common standpoint point P, we have tangent PT, that is tangent to the circle here at point T. And we also have chord B8, that is the extended chord B8, not just the common standpoint point P. So in this drawing, the following equation will be true, that PT square equals to PA times PB. Again, PT square equals to PA times PB. Okay. We can implement Rule 10 in our drawing. In our drawing, here the common standpoint point A. From the common standpoint point A, we have tangent AP, and we also have chord, the extended chord TS touches the common standpoint point A. So all the requirements of Rule 10 are satisfied, and therefore we can implement here Rule 10. According to Rule 10, AP square equals to AS times AT. Again, AP square equals to AS times AT. So I write it now. Repeat again, according to Rule 10, if you focus on the common standpoint point A, AP square equals to AS times AT. AP is A, therefore AP square is A square, and it is equals to AS. AS is 1 times AT. AT in total equals to 1 plus 3. In conclusion, I actually found out that A square equals to 1 times 1 plus 3, so A square equals to 1 and times 1 plus 3, that is 4. So it is A square equals to 1 times 4, that is 4. A square equals to 4. Here we take a root out of this equation, and finally we get that A equals to the square root of 4, that is 2. In conclusion, I should found out that A equals to 2 units in its length. That is to say, line segment AP is equal to A, according to our definition, is equals to 2 units. Likewise, we implement Rule 10 on this common standpoint point C. So from the common standpoint, point C, we have tangent CQ that is tangent to this circle here at point Q, and we have the extended chord ST touches the common standpoint C. So all the requirements of rule 10 are satisfied, and therefore we can implement here rule 10. According to rule 10, we get that CQ square equals to CT times CS. Again, CQ square equals to CT times CS. So I write it down. Repeat again, according to rule 10, if we focus on the common standpoint point C, the following equation will be true, that CQ square equals to CT times CS. CQ is B, therefore CQ square is B squared, and it is equals to CT. CT is 2 times square root of 3 times CS. For the moment, it's very easy to see that CS in total, or SC or CS, it's the same, equals to 3 plus 2 times square root of 3. So in conclusion, I actually found out that B square equals to 2 times square root of 3 times 3 plus 2 times square root of 3. So B square equals to 2 times 3 times square root of 3, and 2 times square root of 3 times 2 times square root of 3 equals to 12. Why? Because 2 times 2 is 4, and square root of 3 times square root of 3 is 3, and 3 times 4 is 12. So we found out actually that B square equals to 2 times 3 times square root of 3 plus 12. So B square equals to, here we substitute 12 by 9 plus 3 plus 2 times 3 times square root of 3. So actually this expression 9 plus 3 plus 2 times 3 times square root of 3 is equivalent to the algebraic identity that states that A squared plus B squared plus 2 times A times B equals to A plus B squared. If we just substitute A in this algebraic identity by 3, and we substitute B by square root of 3, we will get that A squared plus B squared plus 2 times A times B is exactly equal to 9 plus 3 plus 2 times 3 times square root of 3. And according to this algebraic identity, this expression equals to A plus B squared. And therefore, according to this algebraic identity, 9 plus 3 plus 2 times 3 times square root of 3 must be also equal to A plus B squared, when A equals to 3 and B equals to the square root of 3 squared. So actually found out that 9 plus 3 plus 2 times 3 times square root of 3 equals to 3 plus square root of 3 squared. And because of the fact that B squared equals to this expression, and those two expressions are equal to each other, it means that B squared also equals to this expression. In conclusion, we actually found out that B squared equals to 3 plus square root of 3 squared. We take a root out of this equation. And finally we get that B equals to 3 plus square root of 3. Square root of 3 equals to 1.732. And therefore 3 plus square root of 3 will be equal to 4.732. In conclusion, I should found out that B equals to 4.732. So I write it down in the original drawing. B E equals to 4.732 units. And we already found out that A equals to 2. In the next step, we'll implement the Pythagoras theorem on this right big triangle, triangle ABC. Here by PT is the abbreviation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right big triangle, triangle ABC is AC, therefore the square of the hypotenuse is AC square. So AC square must be equal to AB square plus BC square. Repeat again, according to the Pythagoras theorem in the right triangle ABC, AC square equals to AB square plus BC square. From the domain, it is very easy to see that AC in total equals to 1 plus 3, that is 4, plus 2 times square root of 3. So in total, AC equals to 4 plus 2 times square root of 3. Therefore, AC square will be equal to 4 plus 2 times square root of 3 square. AC square equals to 4 plus 2 times square root of 3 square, and it is equals to AB square. From the domain, it is very easy to see that AB equals to x plus 2, therefore AB square equals to x plus 2 square plus BC square. From the domain, it is very easy to see that BC equals to x plus 4.732. Therefore, BC square will be equal to x plus 4.732 square. So in conclusion, I should find out that 4 plus 2 times square root of 3 square equals to x plus 2 square plus x plus 4.732 square. And 4 plus 2 times square root of 3 square equals to 55.7128, and it is equals to x plus 2 square. X plus 2 square equals to x square plus 2 square, that is 4, plus 2 times x times 2, that is 4x, plus x plus 4.732 square. X plus 4.732 square equals to x square plus 4.732 square, that is equals to 22.3918 plus 2 times x times 4.732, that is equals to 9.464x. So, in the left side of this equation we have here 55.7128. In the other side of the equation, in the right side of this equation we have x squared plus x squared is 2x squared. And we also have here 4x plus 9.464x equals to 13.464x. And finally we have here 4 plus 22.3918 is equals to 26.3918. Okay, so in conclusion, I should have found out that 55.7128 equals to 2x squared plus 13.464x plus 26.3918. Here we subtract 55.7128 128 for this equation. And finally we get that in this side of the equation we're left with nothing, 0. That is to say 0. In the right side of this equation we have 2x squared plus 13.464x, and we have here 26.3918 minus 55.7128 equals to minus 29.321. In conclusion, we actually found out that 0 equals to 2x squared plus 13.464x minus 29.321. Here we divide this equation, quadratic equation by 2, and finally we will get that 2x squared over 2 is x squared, and 13.464 over 2 is 6.732x, and we have here minus 29.321 over 2, that is minus 14.66 equals to 0. So we have here x squared plus 6.732x plus minus 14.66 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. This general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. In our specific quadratic equation, that is to say x squared plus 6.732x minus 14.66 equals to 0, the coefficient a equals to 1, the coefficient b equals to 6.732, and finally the coefficient c equals to minus 14.66. And the general formula, or the formula for x, is x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. So in the next step we just have to put the values of a, b, and c for our specific quadratic equation, our specific quadratic equation, inside this general formula for x, in order to find out the value of x in our specific quadratic equation. So we'll do it now, and we'll get here that x equals to minus b. b is 6.732, therefore minus b is minus 6.732 plus minus the square root of b squared. B is 6.732, therefore b squared is 6.732 squared, that is actually equals to 45.3198 minus 4 times a is 1, so minus 4 times 1 is minus 4, times c, that is minus 14.66. So minus 4 times 14 times minus 14.66 equals to 58 plus 58.64, or we have to divide it by 2a. A is 1, so 2a is 2 times 1, that is 2. In conclusion, we actually found out that x equals to minus 6.732 plus minus, and the square root of inside the root we have 45.3198 plus 58.64, that is equal actually to 103.9598 divided by 2. So x equals to minus 6.732 plus minus, and the square root of 103.9598 equals to 10.196 divided by 2. So here we have two solutions that are possible for x. One of those two solutions is a negative solution, because minus 6.732 minus 10.196, it is definitely a negative number, and because of the fact that x is the radius of this circle, and the radius is a length, and the length must be a positive number, the negative solution is irrelevant, is incorrect, and we'll take into account only the positive solution for x. The positive solution for x is as follows: x equals to minus 6.732 plus 10.196 divided by 2. Minus 6.732 plus minus 6.732 plus 10.196 is equals to 3.464 divided by 2. And 3.464 divided by 2 is equals to 1.732. In conclusion, we actually found out that the radius x of the circle is equals to 1.732 units. Repeat again. The radius of this circle x equals to 1.732 units. So in the next step, I will summarize the lecture. In this lecture, we found out the radius of this circle. So in the drawing, we have a right angle ABC. Angle ABC equals to 90 degrees in its size. Line segment AS equals to 1 unit. Line segment ST equals to 4 units. Line segment TC equals to 2 times square root of 3 units. And inside this right angle ABC, we have this circle, and our mission is to find out the radius of this circle. So first of all, we define the center of this circle, this point as O, and we define the radius of this circle, that is the radius that we are looking for in this question, as x. In the next step, we join points O and Q together by straight line. What is the definition of line segment OQ? Line segment OQ starts from point O, that is the center of this circle, and ends at point Q, that is the point on the circle itself. So this is exactly the definition of a radius. Therefore, OQ is the radius of this circle, that is equal to x, according to our definition. We can implement here rule 1, because of the fact that the radius OQ is drawn to point Q, that is the point of tendency of tangent BC with this circle. Therefore, according to rule 1, tangent BC will be perpendicular to the radius QO. If BC is perpendicular to QO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees, according to rule 1. Likewise, we join points O and P together by straight line. OP is the radius of this circle, that is equal to x. the radius OP is drawn to point P, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius PO. If AB is perpendicular to PO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. So actually, in the quadrangle OP BQ, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle, in total the sum of those 4 angles, they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing fourth angle must be equal to 90 degrees in its size. Again, in order to complete the sum of the angles inside this quadrilateral POBQ to 360 degrees, the missing angle must be equal to 90 degrees in its size. So inside quadrilateral POBQ we have 4 right angles. Any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we relate to this quadrilateral POBQ as a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. So in rectangle POQB, the opposite sides must be equal to each other. That is to say, side PO must be equal to the opposite side BQ. But PO equals to x, therefore BQ must be also equal to x because they are equal to each other. Likewise, according to the same rule, in the same rectangle POQB, side OQ must be equal to the opposite side PB, but OQ equals to x, therefore PB must be also equal to x because they are equal to each other. So we actually found out that quadrilateral POQB is not a rectangle but a square. In the next step we defined this line segment AP as A, and we defined this line segment QC as B. Here we implemented rule 10. According to rule 10 is true in any circle. So if we have this circle, and we have the common sum point P, from the common sum point P, we have tangent PT, that is tangent to this circle, here this point C. And we also have chord VA, or the extended chord VA touches the common sum point P here. So in this drawing, the following equation will be true, that PT square equals to PA times PB. Again, PT square equals to PA times PB. Okay? So we can actually implement rule 10 in our drawing. One, because in our drawing, we have, if we focus on this common sum point A, from this common sum point A, we have tangent AP that is tangent to this circle here at this point P. And we also have the extended chord TS touches the common sum point A. Therefore, all the requirements of rule 10 are satisfied, and for that reason we can implement rule 10. According to rule 10, AP square equals to AS times AT. Again, AP square equals to AS times AT. So here, if we focus on the common sum point A, according to rule 10, AP square equals to AS times AT. AP is 8, therefore AP square is A square, AS is 1, and AT is 1 plus 3. So in conclusion, we actually found out that 1 equals to 1 plus 3. That is to say, we found out that A square equals to 1 times 1 plus 3. So A square equals to 1, and 1 plus 3 is 4. So A square equals to 1 times 4, that is 4. So A square equals to 4. We took a root out of this equation and finally found out that A equals to the square root of 4, that is 2. So here A equals to 2. In the next step we implemented rule 10 on this common sum point C. Why we can implement rule 10? Because from the common sum point C we have tangent CQ, that is tangent to this circle here at point Q, and we also have the extended chord ST touches the common sum point C here. So all the requirements of rule 10 are satisfied, and for that reason we can implement here rule 10. According to rule 10, CQ square equals to CT times CS. Again, CQ square equals to CT times CS. Repeat again, if you focus on the common sum point C, according to rule 10, CQ square equals to CT times CS. CQ is B, therefore CQ squared is B squared. And it is equals to CT, that is 2 times square root of 3 times CS, that is 3 times square root of 3. So in conclusion, we actually found out that B squared equals to 2 times square root of 3 times 3 plus 2 times square root of 3. Here we open the brackets on this side of the equation and finally found out that B squared equals to 2 times 3 times square root of 3, and we have here 2 times square root of 3 times 2 times square root of 3 is 12. So in conclusion, we actually found out that B squared equals to 2 times 3 times square root of 3 plus 12. So B squared equals to, here we substitute 12 by 9 times 3. So in conclusion, we actually found out that B squared equals to 9 plus 3 plus 2 times 3 times square root of 3. So this expression 9 plus 3 plus 2 times 3 times square root of 3 is equivalent to a squared plus b squared plus 2 times ab. If we just substitute a by 3 and b by square root of 3, we get that a squared plus b squared plus 2 times ab equals to 9 plus 3 plus 2 times 3 times square root of 3. And this expression equals to a plus b squared. Therefore, this expression that is equivalent to this expression will be also equal to a plus b squared. That is to say, it will be equal to a that is 3 plus b that is equal to 3 squared. So in conclusion, actually found out that this expression equals to 3 plus equal to 3 squared. And because of the fact that this expression equals to b squared, and those two expressions are also equivalent, therefore this expression must be also equal to b squared. In conclusion, we found out that b squared equals to 3 plus equal to 3 squared. We took out of this equation and finally found out that b equals to 3 plus square root of 3. Square root of 3 is 1.732, therefore 3 plus square root of 3 will be equal to 4.732. In conclusion, we actually found out that b equals to 4.732. Here b equals to 97Q is equal to b equals to 4.732, and we already found out that line segment AP is equal to a is equals to 2. In the next step, we implemented the Pythagoras theorem on this right big triangle, triangle ABC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle, the right big triangle ABC is AC, therefore the square of the hypotenuse is AC square, and AC square must be equal to AB square plus BC square. Repeat again, according to the Pythagoras theorem, in the right triangle ABC, AC square equals to AB square plus BC square. AC equals to 4 plus 2 times square root of 3, therefore AC square is 4 plus 2 times square root of 3 square, and it is equals to AB square. AB is x plus 2, therefore AB square is x plus 2 square, plus BC square. BC is x plus 4.732, therefore BC square is x plus 4.732 square. So in conclusion, I actually found out that 4 plus 2 times square root of 4 plus 2 times square root of 3 square equals to x plus 2 square plus x plus 4.732 square. So 4 plus 2 times square root of 3 square equals to 55.7128, and it is equals to x plus 2 square. X plus 2 square equals to x square plus 2 square, that is 4, plus 2 times x times 2, that is 4x, plus x plus 4.732 square is equals to x square plus 4.732 square, that is actually equals to 22.3918, plus 2 times x times 4.732, that is equals to 9.464x. So in this side of the equation we have 55.7128. In the other side of the equation we have x squared plus x squared, that is 2x squared, and we have here 4x plus 9.464x, that is 13.464x. And finally we have here 4 plus 22.4918, that is 26.4918. Here we subtracted from this equation 55.7128, and finally found out that in this side of the equation we left with nothing, that is to say 0, In the other side of the equation, we left with 2x squared plus 13.464x, and we have here 26.3918 minus 55.7128 equals to minus 29.321. So in conclusion, we found out that 2x squared plus 13.46x minus 29.321 equals to 0. So this is a quadratic equation. We divided this quadratic equation by 2, and finally found out that x squared plus 6.74 x squared plus 6.732x minus 14.66 equals to 0. So this is a quadratic equation, of course, and the general formula for quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. We will find out the value of x according to the following formula. X equals to minus b plus minus square root of 3. Again, x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, that is to say x squared plus 6.732x minus 14.66 equals to 0, the coefficient a equals to 1, the coefficient b equals to 6.732, and finally the coefficient c equals to minus 14.66. So we just have to put the value of a, b, and c from our specific quadratic equation inside this general formula for x in order to find out the value of x in our specific quadratic equation. We did it, actually found out that x equals to minus b. B in our specific quadratic equation is 6.732, therefore minus b is minus 6.732 plus minus square root of b squared. B is 6.732, therefore b squared is 6.732 squared, that is 45.3198. Minus 4 times AC, so it is minus 4 times A is 1, so minus 4 times A is minus 4 times 1, that is minus 4 times C, that is minus 14.66. And minus 4 times 14, minus 4 times minus 14.66 equals to plus 58.64. Divided by 2a. A is 1, so 2 times a is 2 times 1, that is 2. So in conclusion, I actually found out that x equals to minus 6.732 plus minus. Inside the root we have 45.3198 plus 58.64 divided by 2. And 45.318 plus 58.64 equals to 103.9598. So inside the root we left only with 103.9598. In conclusion, I found out that x equals to minus 6.732 plus minus square root of 103.9598 divided by 2. So x equals to minus 6.732 plus minus, and the square root of 103.9598 equals to 10.196 divided by 2. So here we will have two solutions that are possible for x. The negative solution is the correct solution. Why? Because of the fact that x is defined as the radius of this circle. A radius is a length, and a length must be a positive number. Therefore, the negative solution is irrelevant, incorrect, and only we take into account only the positive solution for x. And the positive solution for x is x equals to minus 6.732 plus 10.196 divided by 2. And minus 6.732 plus 10.196 is 3.464 divided by 2. And 4.464 over 2 is 1.732. So in conclusion, I actually found out that the radius x of this circle equals to 1.732 units. Okay, thank you very much.